Okay, it's actually good morning, everyone, and I'm actually in here early before this room gets used. I wanted to make a video about Project 2. I'm going to start with an overview and about Part A, and then I'm going to go into some of the details on more complicated parts. So first off, Project 2 is broken down into two major components. Part A is a stock market simulation, which is going to use priority queues and use the STL priority underscore queue data structure. In Part B, you're going to be implementing your own priority queues using several different methods. Now, the AutoGrader will have two different projects to submit to. There'll be a Part A submission, a Part B submission, and each one will have 2 submits per day. And if you decide to use a late day on this project, put the late day system in for one part and it will automatically extend both parts. So you don't have to worry about using like 2 late days to get 1 day. So you put in one extension, doesn't matter which part, it'll automatically extend the other part as well. Okay, so we're going to start talking about Part A. So with the stock market simulation, we want to implement one of the command line flags as we're running the project, and that's verbose mode. Verbose mode is going to tell you about each trade that occurs that gets completed between a buyer and seller. And if you don't work on that first and you get a wrong answer for the number of trades for the day, you don't really have an idea of why it was wrong. So verbose mode is really going to help you get it right along the way. We'll talk about the other flags later on. So I've got a script here to make sure I cover everything I wanted to. So the first thing is about matching up trades is you have to match the highest price buyer with the lowest price seller. And then a trade will happen if they can agree on a price. So how do we get the highest buyer and the lowest seller? That's where the priority queue comes in. We put the buyers in one priority queue, we put the sellers in a different priority queue, and we look at the top of each of those priority queues. And if they can agree on a price, like if someone says, I'm willing to buy for 20, that's the highest buyer, and the lowest seller says, I'm only willing to sell for 100, then they can't make a trade. They can't agree on a price. What if they're trading different stocks, though? What if they've got a price I can agree on, like I'm willing to buy for 50 and I'm willing to sell for 40, but they're trading different stocks? Well, then we need a buyer priority queue and a seller priority queue for every stock. Might that be a lot of priority queues? Sure, it could be, but there's no better way to do it. So in terms of organization, you would be well situated if you have a stock class. And a stock class would have, at first, a buyer priority queue and a seller priority queue. They have to be different because they're going to decide who's the highest, who's the most important in different ways, which means they need different functors. So we'll have a stock with a buyer PQ and a seller PQ. They'll decide how they arrange themselves in different ways. And if you make the stock a class, later on when you discover, hey, I need more data for each class, for each stock, you just add it to the class. Whereas if you start with a vector of PQs and a vector of PQs, and then you'll have a vector of this and a vector of that and a vector of the other, and they're all one per stock, you'd be better off with a class to represent a stock. So what do you put inside of that priority queue? Well, it's going to be an order, like a buy order or a sell order, which means you're going to have a data structure, or class for an order. You're going to have structs or classes to be the functors, one for the buyer PQ, one for the seller PQ. You're going to have to create a bunch of different data types in this project. Now, when we look at the data that we put into an order, be efficient about it. When you read it in, there'll be a string like the word buy or the word sell. We don't want to store the whole string. Strings are big. I could store a Boolean. Is it a buy order or is it a sell order? I could use a character like B or S. I could use an enumerated type, which we're going to talk about a little bit later when we talk about more about the time traveler. So we want those to be efficient, and we're going to store those in the priority queue. Now, when we say that we've got the highest priority buyer or the highest priority seller, it's based on price. What if there are two people who have the same price? I'm willing to sell for 40, and that other seller is willing to sell for 40. Well, then we've got to decide who comes out as the highest priority. We've got to have a tiebreaker, and that is who came first. And if you look at the input file format along with this, one of the things on each trade order line is a timestamp. And the timestamps are arbitrary. They are, you have to check, they should be non-decreasing timestamps. However, what if I've got two people who say, I'm at timestamp 0, I'm willing to sell for 40. And there's more info here on which stock, etc. But I just want to do the relevant stuff at time 0. I'm willing to sell for $40, okay? So now, I've got two orders that have the same price and they have the same timestamp. Timestamp is not sufficient to tell which one came first. The priority queue doesn't have a way to track which one entered the PQ first. The priority queue just says, hey, I've got two orders. I want to know which one is the higher priority. I show it to the functor, and the functor must respond true or false. So if the functor looks at these orders and can't tell which one should come first, it's the fault of the data. There's not enough data there that goes inside the order to indicate which one arrived first. So you're going to have to add another piece of data to each order structure to indicate who came first. So a simple method would be give every order a unique sequence number. We could call it a unique sequence number or an ID or something, whatever makes sense to you, but I could just say, hey, that's number 0. It's the first thing I read in. That's number 1, that's number 2, etc. Everybody gets a different number, and if I get a tie on price, I don't even look at the timestamp because it might not be helpful, but that unique identifier is always going to be helpful. So that's how we break ties. Okay, where am I? Okay, trader info. So the other command line flags are things like trader info, and that's just going to be some info about like how much was bought and sold by a given trader and how much profit they turned that day or how much they lost that day. And that's going to be separate from the stocks because there might be 20 stocks, there might be 40 traders. So we would need, at the high level, we would need a vector of stocks, we would need a vector of traders. And if trader info isn't on, the vector will still exist, but I won't make it size 40. I will remember that there are 40 traders, but I won't resize the vector, I won't put anything in it. For the median mode, there's a whole separate video on the YouTube channel about median mode. Median, though, is going to be on a, it thinks if I'm shaking and I want to undo. For median mode, the idea is I want to know at any given time that the timestamp changes, like if, for instance, here at time 0, someone was willing to buy this stock, whatever stock it is, for, let's say, 50, okay, then they would agree on a price. And if the next stop is timestamp 1, there's any order here, you would say, ooh, at the end of timestamp 0, what was the median price for all the stocks? And this one would now have a median. Whereas other stocks, like if this is stock 2, if stock 1 never got traded, it wouldn't have a median, it wouldn't get printed. So you need a median per stock. So that's another thing that we'll add. Every stock will have a buyer PQ, a seller PQ, and a median mode data structure. And the median mode data structure will exist, but if median mode is off, we'll never fill it and we'll never grow the data inside of it. But watch the other video on how to do the median mode. Now I want to bring up over here, I just want to double check to make sure I've got things in the right order. Okay, so I want to talk about something I should have started with, which is reading input. So let's look at the actual format of an order. So the actual formatting of an order, I'm just going to grab the one from the spec. So actually, let's start at the beginning. So the file has a comment, and it always has the word comment, colon, and then whatever follows it. Then it's got the mode, TL, we're going to talk about TL first. Then it's got enum traders, and the number like 3, enum stocks, 2, and then it's got an order. So the order looks like 0, sell at sell by trader 1, stock 0, for $100, and number, that's the quantity, 44. Okay, so let's talk about reading input. When you start, these first 4 lines are always going to be the same. For the comment, easier than project 1, there is 1 comment. There's not 0, there's not 7, there's 1 comment. Get line, throw it away. For everything else in here, once you're done with that get line, you want to read everything else in here with greater than, greater than. The mode, num traders, num stocks, anything else in the header will always be a word with no spaces in it. Greater than, we'll read that as a string and stop. Then for the mode itself, we could read the TL or PR is the other mode, we could read that as a string. Everything else in the header will be numbers. We can read them as, say, unsigned integers. Hey, I'm making a video for my students, so you can hang out if you want. I'll be done before your class starts. Okay, so we've got those read, and now at this point I could say, oh, I need a vector for my stocks. It's got to be size 2. Traders, do I give trader vector? Depends on whether trader mode is on. When I read everything else in every one of these order lines, we can read it with the greater than. I read a number, I read a string, I read a character. If I read into a character variable, it reads the T and stops, then I can read the integer. If the integer is 1 digit, 2 digits, 3, it doesn't matter. I read into an integer, I get this part. Then I read into a character, it gets the S. I read into an integer, read a character, gets the $sign, read an integer, gets the 100, read an integer for the number, read a character for the number sign, read an integer for the quantity. So I can use greater than for everything other than the comment line. Okay, where were we? So we read a stock. Okay, so once we've read a stock in, we create our order object, we put it into the correct priority queue. So this would go into the seller priority queue for stock 0. Okay, so then, where was I? Okay, we want to talk about time traveler mode. Time traveler is a really cool idea. What we're saying is, if you were a time traveler and you went back in time and you were able to watch those trades go by, you could record when was the best time to buy a stock, when was the best time to sell it, to turn a profit. To simplify things, the time traveler doesn't care about quantity. The time traveler just wants to know the best profit that can be made on one share of that stock. Also, the time traveler is of a category of algorithms called streaming. Streaming algorithms have a few restrictions. You can only look at each input once. I can look at an order once. I can't look at it again. I can't record all of the trades. So the time traveler must be O of n time, where n is the number of orders, and it's got to be O of 1 memory. Whoops, O of 1 memory, this is per stock. Think of it as there's one separate time traveler for each stock. So the time traveler couldn't bring his laptop with him, he couldn't record every piece of data about every trade. He can only write down a constant amount of information about what he finds interesting. Or she, if she went back in time. All right, so the time traveler is recording some information, and we're going to teach you something really, really powerful here that's going to make this easier, is what's called a state machine. The idea of a state machine is in addition to recording the important data, I'm going to record one other thing. I'm going to record what state I am in. So what states are important to a time traveler? Well, we could call it the beginning state, the initial state. I could have a state, I could call it, I have no trades. So I've seen no trades yet. That's my initial state. Now, other states we'll get to in a few minutes. The transitions between states are based on what the time traveler sees. And so every time we read an order in, we show it to the time traveler for that stock. They either write something down or they don't. They might change state or they don't. And then that's it, that's their work. So what the time traveler will change their state based on is this order interesting? And we'll run through a big example in a few minutes, but we want to get the states down. So at first, the time traveler has seen nothing. I show the time traveler a trade that says, someone would like to buy this stock. Well, that doesn't help the time traveler, because if someone wants to buy it, first the time traveler needs someone who's interested in selling it. So the first thing that'll happen that's interesting is the time traveler sees a sell order. So a sell order might cause them to transition to a new state where we could say, I can buy. We could say, I can buy, or I've seen a seller, whichever makes sense to you. You're going to have to reverse things in a sense similar to Project 1. I went north, I came from the south. Here it's, I've seen a sell order, means I can buy. So I can buy. I've changed states. I don't care about the price. I just know someone's selling it. I can buy it. If the simulation ended now, the time traveler would say, I can't make a profit on this because all I have is a place that I can buy it. I've got no one to sell it to. Then, if I see another sell order, I'm going to stay in this state. Now, if the sell price is better, like the first person was selling for 50 and this one's selling for 40, I would stay in this state, but I would change the price and possibly the time that I would buy the stock. If it's a worse price or the same price, I don't change my other info, I just stay in this state. What about then if someone shows me a buy order? So if someone shows me a buy order, I might change to a state where I have a complete trade. But is any old buy going to do? If someone said before, I'll sell for 50, okay, we recorded that. Someone says, I'll sell for 40, that's even better. But then someone says, I'll buy it for 20. That's not going to cause me to get a completed trade. But if they said, I'll buy it for 60, that's a completed trade. So I'm going to transition to a new state if I have a buy order and I like the price. And I like the price if I make a profit. Okay, now I'm in this state. What happens if I'm in this state and I see another buy order with a better price? I'd stay in this state. I'd stay in this state, I would just record the new information. What time and what price I could sell it for to this buyer. Okay, now that works for a long time. What happens though if someone comes along with a better sell price? Like, I'm willing to sell this stock for 10. That's somewhat interesting, but if I replace my $40 buy price, because someone sold for 40, and the day ended, then I'd be stuck with this stock that I bought for 10 and have no one to sell it to. But if someone comes along later and I can make a better profit, I've got to remember that. So we could have a new state here with, let's call it potential. I'll transition to the potential if I get a better sell price. If that happens, I've got to record who was willing to sell it, or not really who, that someone was willing to sell it for 10 and at what time. If the day ends here, I go with the completed trade. Now, what if I'm in the potential state and I see a buy order? I might go back to the completed trade state if they were willing to buy and I can make more profit. Then I would replace my old trade with the new one. I'd go back to the completed trade state. If I'm in either of these last two states and the day ends, whatever my completed trade is, that's the one I will display. Now, I got a big example here. Let's run through the possibilities. Okay, so I'm just going to show the timestamp, whether it's a buy or sell, and the price. All right, so time 0, someone says, I'm willing to buy this stock for $100. Not interesting, because I don't have anyone to sell me the stock yet to sell it to you. All right, so, and then at time 1, someone says, hey, I'm willing to sell that stock for $200. All right, I've seen a sell order that I can buy it at. That's good, I change state. All right, then someone says at a different time, and I'm making the timestamps unique for a while just so we can refer to them, but they don't have to be unique. At time 2, someone says, hey, I'm willing to sell that for $250. That's not interesting because I've already got a better price that I can buy it at. Okay, time 3, someone says, I'm willing to buy that stock for $100. Not interesting. That would be a loss of $100 on the stock. Not going to accept it. Time 4, someone says, I'm willing to buy it for $250. Okay, well, I remembered I could buy it at $200. Now I've got someone who I can sell it to at $250. Now I've got this completed trade where I can make $50. So what I record is, for each thing that I like, I record the timestamp and the dollars. And I change my state over to the completed trade state. Then, let's say it's timestamp 4 again. Someone says, I'm willing to buy that stock for $225. Well, that's a worse profit. I don't care about that order. I just ignore it. Time 5, someone says, I'm willing to buy this stock. We're pretending these are all the same stock number. I didn't want to write it 10 times. I'm willing to buy this stock for $270. Now wait a minute, that's a better profit. I forget this one, not that one. I remember this one, and now I've got a profit of $70. I don't need to record the profit. I can always calculate it from the buy price and the sell price. Okay, then time 5, time 6. Someone says, I'm willing to sell that stock for $100. That's a potential trade. I'd like to buy it for less than $200, but I won't call this my best trade. This is my potential point where I can buy the stock at a better price, but I don't have a completed trade yet. Time 7, someone says, I'm willing to buy that stock for $150. That's not interesting because that would be a profit of $50 and I've already got a profit of $70 remembered. Time 8, someone says, I'm willing to buy that stock for $170. Still not interesting because it's only $70. That's the same that I have. I stick with the original trade. I don't replace unless it's better. And the last one is I have someone willing to buy it for, let's say, $200. Now that's so interesting that I'm willing to forget the old trade. I don't remember that one anymore. I don't remember that one anymore. This is my new one where I can make a profit of $100. What used to be my potential buy is now when I actually will buy it, and this becomes my actual when I will sell it. And I don't have a potential anymore. I transition back to the completed trade state. So if you go through this example, and you can just make a file with these orders, fill them out with the other info that's needed for a complete order, make them all the same stock, run through your time traveler, but the state machine approach will make it a lot easier to get it right. Now, how do we record the state? Really easy. New thing to learn. Enum class, and then we give it a name, like time status. And then we give it curly braces, and then we list every one of our status names. I like to go with uppercase for these because they're user-created things. So we could have like, what do we call our states up here? We've got no trades, can buy, complete, and potential. So we could call this like no trades, completed, or what was, actually I got out of order there, no trades, can buy, completed, and potential. Curly braces, semicolon. So later on, if I have a variable of like type time status, I could call it time status, like status. I can set it equal to time status, colon, colon, and then it would be no trades would be my initial state. And then I can do if statements with that enumerated type, like later on I could say if my status is equal time status, colon, colon, no trades. I can do stuff. Could you do this with a number? Sure. You could read my code and I could say, if status equals 47,423,000. It means nothing to you reading it. You could use a character like N or C, and that's a little bit better, but the enumerated type makes it really, really clear what it is that you're doing and makes it very easy to read. The size of an enum is a little bit big. It's on the order of like the same as an integer, so like 4 bytes. We can go back to our definition. We can add, let's change colors here. We can add into this definition, we can, right in here, we can say colon underlying type, like colon char. It doesn't mean these things are characters, but it means it should use a character as the underlying type. It should only occupy 1 byte. Okay, so that's everything I wanted to cover to help you out getting started on the project and many of the questions we're going to be getting in office hours. We're going to want you to watch the video first. Watch this video. There's a video for the median mode. There's a student recorded video of me that someone recorded during office hours. There's a link to that from the project spec. And I may remake that one at some point, just put it on my YouTube channel instead of having to link to theirs all the time. But make sure you look at each of those before you ask questions about it, because a lot of your questions are going to be answered there. All right, I'll see everyone in office hours or in class.